Hey guys, hope you all are well and staying safe during this quarantine. We're just going to go ahead and finish off this first 8.1.1 note sheet and just continue from where we left off last time. So our next example here, as you can see, it looks a little different from our other ones. This one's actually already in factored form for us as opposed to the other ones being in standard form. So when you're trying to take factored form and put it into standard form, you actually have to multiply out all of these factors. Now that wouldn't be so much to ask if it was just like 2 factors, maybe even 3, but multiplying out 5 factors is kind of a pain, and I'm not going to have you do that. It would just kind of be an outrageous amount of work for this, so we can go ahead and skip that. Okay, and then the degree of the polynomial isn't so bad to find. That one, even though we're in factored form, all we have to do is take a look at how many x's are going to end up being multiplied together. So we know we have 1, 2, 3, 4, 5 x's, which is going to cause us to have a term of x to the 5th if we did multiply it all out. And this tells us that we have a degree of 5. If we have 5 x's being multiplied, our degree is 5. All right, and then coefficients is another thing that is much more convenient to find in standard form. You can't really tell what it is here because you need to combine like terms and everything, so we're not going to worry about that either. And lastly, for coefficients, the leading coefficient, we actually can find that. When you're in factored form, you want to look to see if there's any number in the beginning before all the parentheses. And here we don't have anything, so we can just go ahead and assume that there's a 1 there. So we know that our leading coefficient is a 1. And the constant term, it's really obvious in standard form, but again, it's not too bad to find in factored form. All you have to do is take like the constant term on each factor and multiply them together. So that tells us we have a negative 2 times a 2 times negative 1 times positive 1 times negative 5. And if you multiply all that out together, negative 2 times negative 1 times negative 5, you should end up with a negative 20 for your constant. Alright, so now that we've taken care of those pieces, we are ready to make our graph. The nice thing about factored form is it's the most convenient form to be in when you're trying to draw a graph, because these already tell you right away what your x-intercepts are going to be. So like x minus 2, that factor tells us that we have an x-intercept at positive 2. Remember, you got to take the opposites. Okay, so similarly, x plus 2 is going to tell us we have an x-intercept at negative 2. X minus 1 is going to tell us we have one at positive 1. X plus 1 tells us there's one at negative 1. And then x minus 5 tells us there's one at positive 5. So the only thing left to do is draw in our curve, and the problem here is that we don't actually know like what the shape is going to look like. We don't know if it's going to come down or start at the bottom and go up. And so the best way for us to figure that out is to just go to our calculator, and you're going to go ahead and type in your equation to at least just get an idea of what the shape is of our graph. So just type in exactly what you see. Do not miss any parentheses. I made that mistake a couple of times today. X plus 1. Alright, it looks like it should be right, and then you're going to go ahead and hit graph. And this is our shape. It looks like a super funky graph, but it gives us the information we wanted, which is that it started at the bottom and then it came up. It like shot out of the bottom. So we know that it starts at the bottom and then we know it ends going up. So our graph, and again, I apologize, this graph is going to be no better than the last one. This tablet thing isn't the greatest for drawing graphs. It could be worse, right? It's not so bad. And that is our final graph. It's a reasonable sketch. At least we know what the x-intercepts are, so we can get that part accurate. And then you're all done. You have a general idea of what your graph's going to look like. And finally, this little activity down here is really good practice just to refamiliarize yourself with the vocabulary and two different forms of polynomials. So let's do a couple of examples. We won't do all of them. I'll leave some for you. I don't want to take up all the fun. So this first one here, we know that it's x minus 2 times x plus 5 squared. So right off the bat, just because there's those parentheses, we know that this is in factored form. That's a pretty dead giveaway. Okay, but when it comes to finding the degree, in the last example, all we did was we counted the x's. We said 1, 2, 3, 4, 5. You can do the same thing here, however, watch out for the fact that there's a 2 there. Because there's a 2, you got to count 2 of this factor. Another way you could think about it is that x plus 5 being squared means there's 2 of the x plus 5s. So you could always rewrite it like this, and then you can count and be like, okay, 1, 2, 3 x's are being multiplied together, so my degree is 3. Or you could look at the original and say 1, 2, 3. So the leading coefficient, there's no number in front of our parentheses here, so we can go ahead and assume that there's a 1, and that's all for that one. Let's do a standard form one. Let's do number 8. So for 8, we know that this is in standard form. That's pretty obvious because there are no parentheses. The degree is going to be the highest exponent on an x term, so this 4 is going to be your degree. Okay, and the leading coefficient is the coefficient or the number attached to that term with the degree. So this x to the 4th is the one we're looking at, and because there's no number attached to it, we're going to assume it is 1. Okay, and then we can go ahead and do one more example where there actually is a different leading coefficient. Let's do number 2. So this one is in factored form, and again you know that because there's a bunch of parentheses. The degree is 1, 2, 3. There are 3 x's being multiplied together. And the leading coefficient, now this time there is a number up front and it is a 2, so that's going to be our leading coefficient for this one. And that's it. So again, you guys can go ahead and try the other ones. I'm not going to go ahead and go through all of them with you. But that is all for this note sheet. So we will go ahead and continue with the day 2 of 8.1.1 soon. See you guys later.